All right, guys, this is question number 13. All right, so let's read the whole thing. This says the chemical formula for baking soda is NaHCO3, NaHCO3, and I happen to have a sample that is 168.2 grams, and it's telling me how much of each of these elements are in this. So I'm just going to make a chart as I read, okay? So we've got 45.98 grams of sodium. I'm going to leave myself some space here so I can work. And I've got 2.02 grams of hydrogen and 24.02 grams of carbon and 96 grams of oxygen. All right, so that is, and if we add all this up, 45.98 plus 2 plus 24.02 plus 96, we'll get back to this, right? Because this has to be made of all these components. Now, the question is, what's the percent mass? So remember, percent mass equals mass of the element, that's an E, divided by mass of the compound times 100. So I'm just going to do that 4 times, right? I'm going to do that 4 times. So I'm going to take this. I am going to rewrite it for you. So 45, the grams cancel, so I'm going to just leave them out of my pure math here because gram over gram will cancel, times 100. All right? So if we grab our calculator and multiply that back by 100, I got 27.37%. I can have 4 sig figs because there are 4 sig figs here. All right, let's look at the next one. 2.02 divided by the sample size is this, right? Because here's the mass of the element divided by mass of the compound times 100. All right, so 2.02 divided by, so this is how I do not want to see you doing, I don't want to see you writing out 2.02 and using a division sign like this. I want you to write it like this, okay? Because this is how chemists write this, all right? And chemistry students write this. Times 100, I can only have 3 sig figs, so I'm going to round this to 120%, okay? Hello, sunshine, again. Now, we have 24.02 divided by 168.02 times 100. So 24.02 divided by 168.02 times 100. Now again, we're back to 4 sig figs. So 14 point, let's see what this says. I'm going to do what my calculator says, 295%, okay? So now I've got to round this, 14 point, so when I look at this, I've got to do 3, right? But it's 4 sig figs, so 30, okay? So that's how I would report that, right? That's the correct answer for that. Now let's do the last one. 96. Now here you go. What could you also do? This thing is made of 4 things, 1, 2, 3, 4. For this last one, you could add all these up and subtract it from 100. That would get you that, right? But let's do this. You could also check yourself that way and see if you got the right answer, times 100. All right, so 96 divided by 168.02 times 100, and rounding to 4 sig figs, this is 57.14%. All right, so all we had to do here was the percent by mass 4 times because there were 4 elements in my compound. Excellent work. All right, now let's look at question number 14. All right. Oops, I had too many pages there. Question number 14. All right. Question 14 says that it tells us that the chemical formula for chalk, okay, is CaCO3. So the name of that is calcium carbonate. And it says that we have a 100-gram sample of chalk. Okay, so I'm just writing that down so I can keep up. And it says that this 100-gram sample contains 40 grams of calcium, that's the Ca. It contains, I'm going to move down a little bit, 12 grams of carbon, and it contains 48 grams of oxygen, okay? Even though that's O3, we're just oxygen, okay? All right. So it says, what's the mass percent? Okay, so look at this. If it's a 100 gram sample, don't I know that 40 grams and 100 grams is 40%, right? So I'm just going to do that to show you that for sure. Right? That's 40%. So 12 divided by 100 times 100. Look, those cancel. That's 12%. So this is 48 divided by 100. Times 100 equals 48%. So if the sample size is 100, then the amount of grams also tells me my percent. So here are my percentages. So now it says, what is the mass of each element in a 200 gram sample? In a 200 gram sample. So the percentages are the same, right? So you actually have a couple of different ways that you can think about this, okay? So let's set it up the long way, all right? Let's set it up in using our percent mass formula. So percent mass equals mass of the element over mass of the compound times 100. And then I'll help. Well, let's do one. Let's just do the calcium, all right? So calcium is 40%. So 40% equals the mass of the element is what I want to know. My new sample size is 200 grams times 100, okay? So the first thing I'm going to do is divide by 100, divide by 100. We've already talked about this, right? So this gets us 0.40% equals mass of the element 200, right? So we're going to multiply 0.4 times 200. 200 times 0.4 equals 80 grams. All right? 80 grams. So and you do that for this one, right? So we do that same math. So here's our math, right? Or what can we logically think about? This sample size is twice the size of this, right? It's twice the size. So doesn't that mean that each of these would be twice the size? Is 80 double 40, right? Yes. So you can also do it that way. So you can do this every time, or you could say, logically, you could think that through. Since my sample size, so 200 grams is 2 times 100 grams, right? So you could say that then you would have 80 grams of calcium, and you would have 24 grams of carbon because the 100 gram sample had 12 and the 48 gram sample had it would only ask you for did it only ask us for calcium? Oh, it only asked us for calcium. So that was our answer. Sorry. I was doing way too much work. It only asked us for calcium. So that was our answer. That was the answer over there. But we could have done the other, right? So let's do the 48, right? 48 times 2 is twice as big. So that means that there are 96 grams of oxygen in that 200 gram sample. Forgive me for doing more work than we needed to do. All right, now let's look at number 15. And this is our last problem on this set page. This says a 17.0 gram sample of ammonia, and it tells us the formula there for ammonia, contains 3 grams of hydrogen. Okay, so it has 3 grams of hydrogen are in there. All right, it says what percentage of ammonia is hydrogen? All right, what percent is hydrogen? Well, we use the same percent formula that we used before, right? So percent mass equals the mass of the element is 3. The mass of the compound is 17 times 100. So this is 18%, right? 18% hydrogen. Right? And then it says that there's another question. So one question was what's the percent mass of hydrogen? The next question is how many grams of nitrogen? How many grams of nitrogen are present? Okay, so this gets us back to the law of conservation of matter, right? So this is made up of hydrogen plus some grams of nitrogen. All right? If the mass is this, right, then our math, if you do want to write the math, it's 17.0 minus 3.0. That does not look like a minus sign, does it? Fix it. It looks like a blank. Minus 3.0 equals 14.0 grams of nitrogen. All right? So here we use the law of conservation of matter, and we used the percent mass formula to solve two different questions with a very simple piece of information given to us. I hope you enjoyed this and that it was helpful to you as you work through and correct your own work.